The second chapter, refrigeration cycles and refrigerants. So first, simple vapor compression cycle. In simple vapor compression cycle, the wet vapor, fairly dry vapor, leaves the evaporator and enters the compressor at point 1. So this evaporator and this compressor enters the compressor. This low pressure, low temperature vapor refrigerant is compressed isentropically to point 2. So at point 1, at point 2 isentropically compressed. During compression, the pressure and temperature increases. The temperature at point 2 should be greater than the temperature of the condenser cooling medium. So here temperature increases. The vapor at the end of compression is dry, saturated or superheated and enters the condenser. Then the vapor condensed in condenser and hence change of phase takes place. That means latent heat of condensation is removed by cooling medium. The high pressure saturated liquid refrigerant leaves the condenser and enters the expansion valve at point 3. The expansion of the high pressure saturated liquid refrigerant passed through narrow opening of the expansion valve from 3 to 4. So this receiver expansion valve is 3 to 4, narrowing the function of expansion valve is to throttle the liquid. Here the narrowing of the expansion valve, and the function of expansion valve to throttle the liquid refrigerant from high pressure, high temperature to low pressure, low temperature, keeping enthalpy constant. At point 4, the wet vapor enters the evaporator where it absorbs the latent heat of evaporation and further evaporates. Then change of phase takes place, producing the refrigerating effect. The refrigerant will thus leave the evaporator is a fairly dry vapor and will enter the compressor at point 1. This completes the cycle. So this compressor, compressed air comes to the condenser, then receiver, this throttle valve and this evaporator. Refrigerating effect will occur here. So this compressed, compression nantar condenser and receiver, expansion valve, throttle valve opens, and this refrigerating effect will be here, and again compression. So this is the simple vapor compression cycle. Then components of vapor compression refrigeration cycle. So components are compressor, condenser, receiver, expansion valve, evaporator, dryer, stainer, accumulator, relay and temperature control device or thermostat. So what are the functions of these that we will see one by one. So first, compressor. Compressor is the heart of refrigeration cycle. The low pressure and temperature vapor refrigerant from evaporator is drawn into the compressor through suction valve. Then it compressed to high pressure and high temperature so that it is easily discharges to condenser through discharge valve. Condenser. It consists of a coil pipe in which the vapor refrigerant from the compressor comes in the condenser, where it is cooled from high pressure and temperature to low pressure and temperature by rejecting the latent heat to cooling medium and change the phase occur from vapor to liquid. To increase the heat transfer rate of condenser, find externally must be provided for air cooled condenser. Expansion valve or the capillary. Expansion valve, it is also called throttle valve. The function of this valve is to allow the liquid refrigerant under high pressure and temperature to pass at a controlled rate by reducing pressure and temperature. While passing the liquid refrigerant through valve, a small quantity of liquid refrigerant flashes or evaporate due to friction, but greater portion is vaporized in evaporator at low pressure and low temperature. This throttling process is irreversible process. Then evaporator. Evaporator is a coil of pipe in which liquid vapor refrigerant at low pressure and temperature is evaporated, and refrigerant phase changes from liquid to vapor by absorbing latent heat of vaporization from the medium which is to be cooled. Dryer strainer. The function of the strainer is to remove moisture and impurities from the refrigeration system. It is tubular metal container arranged in circuit. The drying and purifying agent is silica gel with an addition of cup-shaped inlet screen which performs filtering and drying function. Accumulator. It is a large cylindrical shell which trap the liquid refrigerant droplet and avoid to the entry of the compressor, which may damage the compressor. Relay and temperature control device or thermostat. During startup, high torque is required for compressor. This torque is achieved by starting relay. The relay is of electromagnetic type connected in series with main winding. During starting, high current flow through relay and contact closed, putting the start winding into circuit. To control the temperature inside the refrigerator, there is thermostat whose sensor is connected to the evaporator. The thermostat setting can be done by round knob inside the refrigerator compartment. When the set temperature is reached inside the refrigerator, the thermostat stops the electric supply to the compressor and compressor stops, and when the temperature falls below certain level, it restarts the supply to the compressor. Now refrigeration of pH and TS diagram according to condition of cycle. Cycle with dry saturated vapor after compression. There are many cycles used to increase the coefficient of performance of the cycle. Some of them are as follows. Cycle with dry saturated vapor after compression. Cycle with wet vapor after compression. Cycle with superheat vapor before compression. Cycle with superheated vapor after compression. Cycle with undercooling or subcooling of refrigerant. So there are different cycles that we will see one by one in next lecture. Superheating cycle, subcooling, pressure, enthalpy, temperature, entropy diagram, all we'll see in next lecture.